Hi guys, this is Mr. Richard. So in this video, we are going to look at MAE 201M, right? So this is a module for UNISA students who are doing senior and intermediate phase. Right. So as we are preparing for, November 2022, I want you to listen carefully as we tackle this question. This video is part of revision, actually. It's part of revision. Listen carefully, and I would like to emphasize that this paper consists of algebra and patterns, as well as functions. Right. If you're new to this video, or to this channel, sorry for that. If you're new to this channel, don't forget to click the red button and subscribe. Come on, 1, 2, 3, let's go. Thank you. Let's grow the community. Right, we'll start with the first question. Question 1. Use 2 examples to explain what is meant by algebraic thinking. Well, guys, algebraic thinking has to do with generalizing arithmetic operations. It is also has to do with manipulating numbers, using words and symbols, right? And showing a relationship, or yes, showing a relationship between numbers, right? For example, I could say Richard has 5 marbles, and along the way, when he was on the road, he lost 2 marbles along his way. So how can we put that into practice? Let me show you how you can work with 1.1. So at 1.1, remember I said that Richard, this is R, Richard has 5 marbles. Along his way, he lost 2 marbles, right? Yeah, along his road, when he was walking on the road, he lost 2 marbles. So how can we put this into symbols? We could say, and numbers, we could say 5 subtracted by X. Then since Richard has 5 marbles and he lost 2, that means he was left with 3 marbles. So let's see, how can we be sure that Richard lost 2 marbles? We can do this by solving for x. Let's transpose 5 to the other side, so we'll be left with negative x. Okay. Then let's take 5 to the other side. It will be 3 minus 5. That will be minus 2. Then when we divide both sides by negative, it will be positive x, and x is equals to 2. So in other words, Richard lost 2 marbles along his way while he was walking on the road. We can prove that by saying 5 minus 2, it's 3. So that's how you can work with 1.1. Note that at 1.1, they want you to explain using 2 examples. You can say, when you write, you could say, what is meant by algebraic thinking. First, you could say, algebraic thinking has to do with manipulating numbers, using words as well as symbols, and generalizing, as well as showing the relationship between the numbers. Then that will be the first example. A second example, you could say maybe Richard has 5 marbles. He lost 2 marbles along his way. Then you can show it algebraically. So that's how you can work with 1.1. We can go to 1.2. There are different types of models: pictures, written symbols, and oral language, and real life situation. Choose one type and explain how you will use modeling to explain the concept of perimeter to your learners by using examples. Well, guys, first thing first, let's choose a shape such as a rectangle, right? A rectangle, it's a quadrilateral with 4 sides, right? With 2 lengths and 2 breadth. So what is a perimeter? First thing first, when you want to explain perimeter to your learners, this is what you should do. Perimeter, um, perimeter is the distance around the shape. Perimeter is the distance around the shape, right? Perimeter is the distance around the shape. Okay. So what do we mean by that? Let's show this using an example so that we can get that 6 marks, guys. We should be very smart. Let this side be L, which is length, and this side be L, which is length, and this side, which is B, which is width or breadth, and breadth there. So how can we calculate how can we calculate the perimeter? We can add L plus L, that's 2L. Base and base, that will be 2B. Right, so this is how you can calculate the perimeter. So, right, some could use X and Y. It's still the same thing, guys. It's still the same thing. So I think now we can go to question 2. Well, at question 2, we are working with algebraic expression as well as equation. So question 2 requires you to have knowledge of equation, the difference between equation, expression, and knowing how to factorize. Right, remember that an equation, we know it by an equal sign. When it's an equation, you solve, but when it's an expression, you simplify. I like to say simplify. You just simplify. For factors, factorization, you look for the factors, right, that satisfy the expression. So at 2.1, write the following expression in descending power of y. When they say descending power, we will start with the one that has the highest exponent and end with the one that has a lowest exponent. If it was ascending, it will be from the smallest to the biggest exponent, right? Let's put this into practice. First thing first, we can start with this one, which is, it has power of 5, negative x cubed power of y. So in this case, let me just write it here. So it will be negative x cubed y to the power of 5. Then the one that follows, it's with the highest exponents, that's definitely, it will be negative 3y to the power of 4. After negative 3y to the power of 4 will be what? Let's see. Which it will be this. It will be x squared y to the power of 3. Then after that, that will be negative 5y squared. Then lastly, with the lowest exponent, that will be plus 2xy. So that's how, guys, you can work with 2.1. Then I want us now to visit 2.2.2. Let's go to 2.2.1. At 2.2.1, they want you to factorize the following. But we can see that there's something that we know here. That's a difference of two squares, right? We also have a highest common factor here. So in this case, how can you simplify such? For difference of two squares, what are the factors of c squared? That will be c and c. Factors of b, that will be b. So we are going to have plus b, c plus b, and c minus b. We are done with that first part. Then the second part, we can see that 2a, it's common, right? So we can factor out 2a. So we are going to say negative 2a. What are we going to be left with? Let's put b here. Because if we say negative 2a multiplied by b, that will be negative 2ab, right? Okay. So how can we go to 2ac? All right. To go to 2ac, what do we need? We need just c here. It will be plus c, because negative 2a times c, it will be negative 2ac. Then already you have factorized. You can continue further from here. We have common brackets, which is c plus b and b plus c. It's the same thing. So we will take one thing here. Take one bracket. So we'll be left with c minus b minus 2a. So we shall place this as c minus b minus 2a. So that's how you can factorize such thing. First thing, check, is there what type of factorization is here? We can see that it's a difference of two squares. This one, it's factorizing by finding a highest common factor. The highest common factor, it's 2a. So that's how you can work with 2.2.1. Let's go to 2.2.2. Right, let's put it into practice. At 2.2, we can also see that it's a difference of two squares. But we don't have 18. Can be kind of tricking us there. But what can we do? We need to be smart in terms of this. So we can see that 2 is divisible in both expressions here. So it will be 2, open the bracket, 2 divided by 18, that will be 9. So we'll be left with 9x squared. 2 divided by 32, that will be 16 y squared, right? So we can continue further. Let me write it in a paper so that I can get enough space then. Remember that we have 2 open the bracket 9x squared minus 16y squared. What is inside the bracket is a difference of 2 squares. So what are the factors of 3x squared, of 9x squared? Sorry for that. That will be 3x, right? Okay, the factors of 16, that will be factors of 16, that will be 4y, right? So we are going to have 3x plus 4y. Yes, so that's how you will get that 3 marks, right? Let's go to 2.2.3. We are going to 2.2.3. Let's revisit 2.2.3. At 2.2.3, we are given a trinomial then, right? So we need to factorize that trinomial, but it's quite easy to work with 2.2.3. Let's look at the factors of 4a squared. Factors of 4a squared, that will be 2a and 2a. Factors of 9, that will be 3. But guys, look at the sign. The last sign tells you if it's positive, that means both brackets should be negative here. Signs are very important. Without signs, you will die. So let's not die. Let's know that when it's positive here, it will have same sign. When it's negative at the last sign, it will have different sign, right? So in this case, it will have same signs, which is negative and negative. So we are going to have 2a as well as 3 minus b here. Okay. That's how you can work with this. You can check back by saying 2a times a, that will be 4a squared. It's not 9 here, it's a, guys. 2a times 2a, it's 4a squared. And negative 3b times negative 3, that's that will be 9b squared. You can also check using a FOIL method so that you confirm that your answer is correct. Now we are going to 2.2.4. In factorizing the expression 9 squared plus 12ab plus b squared plus 4b squared, one of your learners wrote the answer as which is incorrect, 3x plus 2b and 3x plus 4b. Explain how the learner was thinking when she wrote the answer, and then explain the correct way of finding the answer. What could be the learner was thinking of here? Yeah, we will find out by solving this by factorizing this trinomial. Let's put it into practice. All right, let's put this into practice. We are given 9a squared plus 12a plus 4b squared. Remember that the solution for learner was 3x plus 12b and 3x plus 4b, which is incorrect. It could be the learner was thinking that we should break 12ab. That was the error that he made. So let's rectify it, right? We'll rectify it. First thing, the learner was supposed to find the factors of 3a squared, in which is going to be, in which is going to be 3a as well as 3a, not 3x. 3a and 3a. Then, what about the factors of 4b squared? That will be plus 2a, 2b, sorry for that, plus 2b. We can recheck by saying 3 times 3a, that will be 3a squared. 2b times 3a, that will be 6b, 6ab, and 2b times 3a, that will be 6ab. 2b times 2b, that will be 4b squared. Okay, then when we add the middle term, we are going to have 12a. Okay, 12ab. So sorry for that, it should be 12ab here. 12ab plus 4b squared. So that's how, first thing, the learner was supposed to find the factors of 9a squared, which is 3a and 3a, and also find the factors of the last term, which is 2b and 2b. Right, and take note of the sign if it's positive, or if it's positive here. Remember, I told you that the signs will be the same. So here in this case, it will be positive. It will be positive because your middle term is positive. Mind your decision when it comes to signs, right? Let's go to 2.3. We are on our last part of our video. Remember that in this video we are going to focus with question. We are going to focus on question 1 and question 2. In our next video, we are going to work with question 3 and question 4. Right, let's put 2.3 into practice where we are solving the equations. Right, solve the following equations. We are given 4y, open the bracket, 3y plus 2 is equals to 20. First thing first, we need to write this in a standard form. So it's going to be 12y squared plus 6y, right? As well as, is it 6y? No. 4y times 2, that will be 8. 8y. Then let's transpose, we can transpose 12 to the left hand side. It becomes 20. Then from there, equated to 0. Okay, equated to 0. That's how, yes, we write this in a standard form. You write this in a standard form. So let's put this into practice. Let's do it. Well, since we are solving for y in this case, guys, to make things simpler, take the first coefficient and divide it by, can we divide by 12 there? No, it cannot satisfy the whole expression, but we can. Let's try 4. 12 divide by 4, that will be 3. So in this case, we have divided by 4. So that will be 3y squared. How many times does 4 goes into 8? It goes twice, right? So it will be 12y. How many times does it go to 20? 5 times. So that's 0. Okay. How can you solve such trinomial? We can solve this kind of quadratic trinomial using a cross method. So what are the factors of 3y squared? That's 3y and y. The factors of 5. Okay, the factors of 5, it will be, let's see, 5 and 1. Okay, 3y times y, that will be 3y. 5 times y, that will be 5y. Okay, to make things simpler, we need to, these factors must satisfy the middle term. Okay, in this case, let me take a calculator and show you how you can do this. If you say 5 plus negative, what is that? Plus negative 3, that will be 2, yes. So these factors does satisfy our middle term. So what can we do there? Let's factorize 3y as well as and y, so and 5 here as well as 1. Okay, so what about the signs? How can you work out the signs? 5, it's a bigger number. It will take a positive sign. This one will take a negative sign. Then you are going to equate everything. So you are going to say 3y plus 5 is equals to 0. Okay, or y minus 1 is equals to 0. Okay, from this case, you can take 5 to the other side, it's negative 3, divide both sides by 3. So we are having y is negative 5 all over 3. Okay, or take negative 1 to the other side, y is equals to 1. So that's how you can work with 2.3.1. Let's go to 2.3.2. 2.2.3.2, we need to write this first in the standard form. So it's going to be x squared minus 8x. Take negative 12 to the other side. It changed the sign. It becomes a positive 12. So we're having x squared minus x plus 12 equated to 0. So how can we solve this further? Okay, to solve this further, we could say x, the factors of 12 that will satisfy the middle term, that will be 6. So let's think about negative 6 and minus 2. Why I put both negative? Remember, I told you that check your last sign. If your last sign is positive, it means your signs will be different. Since the middle term is negative, so we are going to have negative and negative here. So when you equate everything to 0, this will be equated to 6, or x is equals to 2. So that's how you can work with 2.3.2. So now let's put this into practice. Let's go to 2.3.3, which is x squared minus 3x plus 1 equated to 0. Right, let's do 2.3.3, which is 2x squared minus 3x plus 1 equated to 0. Solve for x in this case. So first thing first, guys, let's find the factors of 2x squared. That will be 2x and x. Factors of 1, it's 1 and 1. But let's check them that they give us the middle term. 2x times 1, that will be 2x. And x times 1, that will be x. Yes, they do give us the middle term. If I say negative 2x minus x, I will get negative 3x, which is true. So in this case, we are going to have 2x as well as x, the factors 2x and x, and 1 and 1. The signs will be minus. Remember that if it's positive here, your signs should be the same. So we equate everything to 0. 2x minus 1 equated to 0, or x minus 1 equated to 0. Okay, so this will be 2x is equals to 1, divide both sides by 2. X is equals to half, or x minus 1 is equals to 0. X minus, okay, this will be positive 1. So you can check here by substituting 1, or by substituting half there. When you substitute 1, it will be 2 times 1 squared, that will be 2. And if you put 1 here, negative 3 times 1, that will be negative 3, right? So 2 minus 3, that will be negative 1, plus 1, that will be 0. So definitely it's correct. So now we are going to 2.4. Okay, at 2.4, use the equation 3x squared minus 14x minus 5 equated to 0 to show how you will teach the learners to derive the quadratic formula. 8 marks. When we are deriving a quadratic formula, we will have to complete the square. I'll show you how you are going to complete the square. We are going to complete the square so that we apply a quadratic, so that our solution will be in a quadratic form, right? So in this case, you are going to solve for x, you are going to complete the square, because the equation of a quadratic was derived from completing the square. To make things simpler here, what you could do is just say 3x squared minus 14x and equate everything. Okay, transpose negative 5, right? You want to complete the square, right? Then divide both sides by 3, since we have a coefficient here. Divide both sides by 3, divide both sides by 3. This cancel, we are left with negative x squared 14 all over 3, because 3 can't get to 14. So we have negative 14 all over 3x, which is 5 all over 3. So what does the completing the square states? It states that you have the middle term, right? We have the middle term. In other words, you're going to say negative 14 all over 3 times half, and we square it. What are we going to have? So take your calculator there. Negative 14 all over 3 times half, that will be 49 all over 9, right? So we are going to have 49 all over 9. It's the completing the squared states that you have the middle term and square it, you add and subtract. That's the rule. So it's going to be 14 all over 3x. You add 49 all over 9, right? You also subtract 49 all over 9, which is equated to 5 all over 3. So from here, what are we going to do? there are three things that complete the square. So what are the factors of x squared? It's x. We take the first sign, which is negative. Factors of 49, that will be 7. Factors of 9, that will be 3. You will then square. Transpose negative 49 all over 9. It will be 5 over 3 plus 49 all over 9. So in this case, we are going to have x minus 7 all over 3 squared. Then what is 5 all over 3 plus 49? 49 all over 9. Let's see. That will be 64 all over 9. You are not done. You're supposed to root both sides. Remember solving in this case. So when we root, the root and the square will cancel. We're left with x minus 7 all over 3. So what is root 64 all over 9? That will be 8 all over 3. Remember, it's plus or minus. Then you're going to take negative 7 all over 3 to the right hand side. It's going to be negative. It's going to be positive 7 plus or minus 8 all over 3. Then let's find the solution in this case. Okay. Right. So 7 all over 3. We have it's the same as 7 all over 3 plus 8 all over 3, or 7 all over 3 subtracted by 8 all over 3. Since the denominators are the same, let's just say 7 plus 8, that will be 15. So we are going to have 15 all over 3, or we could say 7 all over 3 subtracted by 8 all over 3. That will be minus 1 over 3. So that's how you can work out such question. So first thing first, your learners should divide the by 3 and right, and after that they will apply what we call completing the square. So that's how you can work with 2.3. Guys, hope you find it useful. Let's go to 2.4. Let's go to 2.5, right? A man is 9 old as his son now. And okay, let's to make things, they said a man is 9 old as his son. Let me write it here. Okay, sorry. Okay, now, okay, let the son be x, and the man, they said a man is 9 times as old as his son, so that means a man will be 9x in this case. That's it. That's for now, right? In 4 years time, in future, he will be 5. In 4 years time, he will be 5 times as old as his son. How old are they currently? So the son, meaning that the son will be x plus 4. Yes, we'll add by 4 in 4 years time. Then what about the man? The man will be 9x plus 4. Remember that the man it's 9x plus 4. We are not done, guys. So from here, they said he will be 5 times old as his son. Okay, so he will be 5 times as old as his son. Remember that his son in 4 years time will be x plus 4. So we have our equation there. So that's how you can work with 2.5. But we are not done. Let's solve for x so that we can know how old are they currently. Yes, we need meaning now, right? Let's continue with 2.5. Yes, let's put this into practice. 9x plus 4. 5 times x, that will be 5x. 5 times 4, that will be 20. Algebra, the like terms. So we are going to take 5 to the other side. It will be 9 minus 5x. Okay. Therefore, let's take 4 to the other side. That will be 20 subtracted by 4. What is 9 minus 5? That will be 4x, isn't it? 9 minus 5, 4x, right? And 20 subtracted by 4, that will be 16. So how many times does 4 goes into, how many times does 16 goes, how many times does 4 goes into 16? It goes 4 times, right? 16 divided by 4, that's 4 times, right? So the man now, it's 9 times 4. That's the man. So that will be 9 times 4, which is 36. The man is 36 years old. So what about the son? The son is 4 years old currently. So that's how we should work with such. So hope you find this video useful, right? Let's go to, we are going to 2.6, right? 2.6, we are going to work at 2.6. Let's put this into practice, right? At 2.6, which is the last question, the length of a rectangle is 4 centimeters, more than its width, more than the breadth. Let's draw, guys, such questions, put this into a drawing so that it becomes easier. They said that the length of a rectangle is 4 times, is 4 more than, so it's 4 more than its width, so it will be x plus 4, meaning that the breadth or the width is x. Let the breadth be x, so in other words it will be x plus 4. It's more, then you add, it will be x plus 4. So, and the area is given as 60. So when we write the formula, it will be length times breadth. So we need to find the dimensions. 60 is equals to, we have x times x plus 4. Let's put this x times x, that will be x squared. X times 4, that will be 4x. So let's write this in a simplest form. Okay, let me just get space there. It will be x squared plus 4x. Transpose 60. It will be minus 60 there. Okay. So to make things easier, so we are going to say the factors will be x plus 10. The factors of 60, remember it's 10, right? And this will be, okay. This will be the factors of, okay, we have 6, right? So remember that 10 times 6 is 60. So x will be negative 10. We can't have a negative distance. This can be NA. You write NA, not applicable. So the applicable answer will be x is equals to 6. I'm sure you're going to transpose negative 6 to the other side. Is going to be positive 6. So the dimensions will be, in this case, will be for the width will be 6. As for the length, it will be 6 plus 4, which will be, the length will be 10. Yes, it will be 10 centimeter. And 10 centimeter times 6 centimeter, that will be 60 centimeter squared. Hope you find this video useful. Don't forget to subscribe and share and comment. We love you. See you on the next video on question 3 and question 4, MA 201M, May, June 2022. We are reviewing for October, November 2022. See you on the next video.